In this video, we're going to introduce expressions with rational exponents. If you look at this expression right here, 27 to the 2/3, here's the rational exponent, or 2/3 is the rational exponent. That is the exponent that's a fraction, and we're going to introduce what those mean. Okay, so in general, the denominator represents a root. Denominator of 3 represents a cubed root. Okay, so let's evaluate this. 27 to the 2/3. First, we do the root, that is the denominator. So first we're going to take the cube root of 27. The cube root of 27 is 3. And then we're going to, so that's the cubed root, but now here we still have to do this exponent of 2, so leave that in the expression. So we have 3 squared, which is 9. All right, next we have the expression minus 27 to the 2/3. Let me just remind you of an example that we did previously in the first chapter in this class. We did things like this, minus 2 to the 4th, for example. And we said this is the same as minus 1 times 2 to the 4th, which is minus 1 times 16, or negative 16. In other words, this exponent applies to the 2 only, and not to the negative sign in front. We're only taking the 4th power of 2, and that's because of order of operations. Exponentiation becomes before multiplication by minus 1. So here we apply the same concept. Okay, so now we're doing minus 27 to the 2/3. So first we're going to take the cube root of 27. So the cube root of 27 is 3. All right, we still have this squaring, this exponent of 2, and again, we're only squaring the 3. All right, so we have minus 9. Here we have a fraction raised to a fraction 25 over 4 raised to this fractional exponent. So just like before, we're going to start. We'll start by doing the denominator, that is square root. So we're going to take the square root of 25 over 4, first the square root of 25, and divide by the square root of 4. Okay, so the square root of 25 is 5, square root of 4 is 2. And now we're still going to do cubing of the numerator and denominator. So 5 cubed is 125, and 2 cubed is 8. Okay, now we have a negative exponent, a fraction to the negative exponent, minus 2/3. So remember the rule. Let me just show you on the side here. If we have a fraction raised to a negative exponent, take the reciprocal of the fraction and change the exponent to positive n. All right, so we'll apply that here. We'll take the reciprocal okay, so that's the reciprocal, and change minus 2/3 to positive 2/3. All right, now we're going to do the cubed root, numerator and denominator. All right, we can attach this minus sign to either the numerator or denominator. So let's say we attach it to the numerator. So first we're going to take the cube root of minus 27. So that's minus 3. This time the exponent applies to the number with the sign because of these parentheses. So the parentheses include the minus sign. Okay, and now we're going to take the cube root of the denominator. Okay, we still have to square. Keep the parentheses there because the squaring applies to minus 3 over 4. So first we're going to square minus 3, and we get a positive 9. And then square 4, and we have a 16. In number 5, we're applying a negative exponent to 25. Again, this exponent applies only to 25, not to the negative symbol. So we have minus 25 to the negative 1/2. So first we're going to just take the reciprocal of 25 and change the negative 1/2 to a positive 1/2. So, all right, so in the denominator, we're going to take the square root of 25. In number 6, we have an expression involving exponents raised to a fractional power. All right, so like before, we're going to first do the denominator, or the fifth root. So start by taking the fifth root of 32. All right, that's 2. Next, we'll do the fifth root of x to the 10th. So we take the fifth root by dividing 10 by 5. And we get 2, so that's x to the 2. Now the fifth root of y to the 15. Again, divide 15 by 5. And we have y cubed. All right, now we're going to square everything. 2 squared is 4. X squared squared is x to the 2 times 2, x to the 4th. And y cubed squared, y to the 3 times 2, y to the 6. In number 7, notice the minus 8 is in parentheses. So we're going to take the cube root of minus 8. We'll start with that. All right, again, we're doing the denominator first. Cube root of minus 8 is minus 2. The cube root of x to the 12, we'll divide 12 by 3. We have 4, so that's x to the 4th. Cube root of y to the 21, divide 21 by 3, and we have 7. So that's y to the 7th. And now we're squaring. We're using this numerator. All right, we're going to square negative 2, and that would be positive 4. Square x to the 4th, multiply the exponents, and we have x to the 4 times 2, x to the 8. And then y to the 7th squared is y to the 7 times 2, y to the 14. In the next few problems, we're going to use the Pythagorean theorem to get some information about a right triangle. All right, so let's write down the Pythagorean theorem. First, let's just draw a picture of a right triangle. And these are the legs. We'll label them A and B. And we always label the hypotenuse with the letter C. The Pythagorean theorem says that we have the following relationship. A squared plus B squared is equal to C squared. All right, that's the Pythagorean theorem. All right, so in number 8, we're asked to find the hypotenuse of the right triangle with legs 9 and 12. So we have a right triangle. Legs 9 and 12, and we have to find the third side, the hypotenuse. So we're going to use this Pythagorean theorem. We're going to write down A and B are 9 and 12. So we'll write 9 squared plus 12 squared is equal to the hypotenuse squared. We're calling that x squared. All right, so let's just figure this out. This is 9 squared is 81. Okay. So we have 225 is equal to x squared. So x is the square root of 225. And we recognize that 225 is a perfect square. It's equal to 15 squared. So x is 15. So that would be C. That would be the hypotenuse. All right, now we want to find the third side of the right triangle with one leg of length 5 and hypotenuse of length 8. All right, let me just show that over here. Okay, so again, let's just draw a picture. So one leg has length 5 and the hypotenuse has length 8. So put that as the long side next to the across from the right triangle, and this is the side that we want to find. So let's write out the Pythagorean theorem. 5 squared plus x squared is equal to 8 squared. Making sure to substitute 8 for C, because 8 is the hypotenuse opposite the right angle. So we have 25 plus x squared is equal to 64. And we're just going to subtract 25 from both sides. So we have x squared is equal to 39, and x is the square root of 39. In number 10, we're also going to use the Pythagorean theorem to see if the following 2, 5, and square root 29 are the lengths of the sides of a right triangle. Okay, so here are the various lengths, 2, 5, and the square root of 29. And we have to make sure, we want to see if the following relationship is satisfied. Okay, do the sides satisfy this? These three sides, do they satisfy this equation? We have to make sure that we substitute for C whichever is the longest side or the largest number. All right, so what about, well, obviously 5 is bigger than 2. And which is larger, 5 or the square root of 29? Well, 5 is the square root of 25, so the square root of 29 is larger, so this must be C. So we substitute 2 squared plus 5 squared, and is that equal to the square root of 29 squared? That's what we want to determine. All right, so that is 4 plus 9 equal to square root of 29 squared is 29. Sorry, not 4 plus 9. 5 squared is 25, so let's write that over here. Is 4 plus 25 equal to the square root of 29? And obviously it is. So that means that these are the lengths of the sides of a right triangle. So the answer is yes. Okay, number 11 concerns a rectangle. So we have a rectangle with sides of lengths 3 and 5. And we want to find the area and the perimeter. Well, let's remember that the area is equal to length times width. So in this case, that would just be 5 times 3, or 15. Okay, now the perimeter is twice the length plus twice the width. So in this case, that would be 2 times 5 plus 2 times 3. So that's 10 plus 6, or 16. Now let's just imagine we had put units here. All right, so let's say this is 3, let's just say this is inches. 3 inches, 5 inches. Then the area 15 would be square inches, or sometimes you write it like this, inches squared. And the length would simply be in inches. That is, the perimeter would simply be in inches, because it's a type of length. So it's a one-dimensional unit. Number 12 is about a circle, and this one says a circle has diameter 12. Now be careful to read this properly, or read it carefully. Sometimes we're given the radius, and sometimes we're given the diameter. This time we're given the diameter. Diameter consists of 2 radii. So here we have a diameter of length 12. That means the radius is of length 6. So the radius is 6. Okay, so we want to find the area and the circumference. Well, the area is equal to pi r squared. So that would be pi times 6 squared, or 36 pi for area. And circumference is equal to 2 pi r. So that would be 2 pi times 6, which is 12 pi.